2 guys or 3 guys on hold so that they can work on those defects. Okay, so coming to the Coveware part, what does Coveware have in this respect? So we have platforms and services for integrating multi-vendor tools to provide a unified software development environment. This will provide an integrated view of all the ALM tools. The data visibility is going to be very good across all the tools. We also provide a central repository where all these data from all the tools can be mirrored into this repository, and that can be used for generating your consolidated reports, tracking data, traceability, dashboards, all these things. And the traceability, reporting, and dashboards, these happen on real-time consolidated data. So the data is synchronized from the source tools and then the reports are produced. So if you make a change now in your system, it's going to show up within a minute in your dashboarding panel, and that's going to help your manager to take corrective actions immediately. Then we take care of process automation across different tool boundaries. The Coveware product can be used to measure process adherence, and thus it can be used to enforce process compliance at different stages of the software development or ALM. And our integration technology, we call it the Omnibus integration platform, that is built on SOA architecture and it's based on the ESB model, so it's very easy to build connectors and hook it onto the bus, and that's immediately going to get connected to all the other tools in the bus. And we have connectors for all the major tools in the market, so I'll be showing you a slide regarding that. This is the architecture of Omnibus from a high level. We have a central processing engine or the bus and separate adapters for separate tools, and some plugins are there which enable the IDE users to get a view of any of the artifacts being stored in these tools. They can see it from within their IDE, modify it, and also create new items inside those tools directly from their IDEs. And the Coveware application here is a web-based application that is used to configure the integration rules. This is the current Coveware scenario where we are supporting 45 plus tool integrations, and if you look carefully, there are integrations available for all the different silos of software development or application lifecycle management, so Requisite Pro, RRC for requirements management, and also some tools like SonarQube, which are used to generate real-time matrices from the code, and also static analysis tools like Find Bugs, FXCorp. These are also integrated so that these matrices can be produced real-time and can be used to predict the future matrices. So saying that, it's time for a short demo where I'll be showing you how some of the predictive matrices are working in some real projects. So let me just start with the presentation, start with the demo here. Okay, so what we see here is the Coveware application. This is a particular artifact that we are tracing. It's the build management, build artifact. So there are different artifacts available under each of these headings. So under project management, you can see some artifacts, requirements management. And so we were in build management and looking at the builds over here. So these are 3 different Eclipse projects that are being seen in this particular view. And if we look at these numbers, so these are the project names, and this is the cyclomatic complexity that is there in these projects till now. And these are all current projects which are being worked on. And the predicted issue number is showing up over here. based on the models that we have used to derive this. So this is a real-time current number, the complexity based on how you're writing the code. This is showing up, and this is the prediction based on the models that it predicts so many defects will be produced. And you can see the ratio between the complexity and the predicted number of issues is also quite close. In fact, this one has a variance, but the other two you can see that 0.23 and 0.2 is the ratio between these. So this depends on the complexity of the model that is used to generate these prediction numbers. Now what I will do is I will go into this project and I will modify the code, and based on this integrated ALM solution from Covair, we will see that that is going to immediately impact the complexity and also the number of predicted issues. So let's go into the development machine and make a change in the code. Okay, so I've logged on to my development machine, and we can see that this is the project name over here, Covair internal project. And what I'm going to, okay, just give me a second here. Alright, so what I'm going to do here is I will delete a particular class file from this project, and that should impact my complexity. Okay, so I think the remote desktop is not connecting properly. Okay, so there you go. I get to see the delete message now, and I'm going to just delete this, and I'm going to build this project. So this is the end file used for the build, and I'm going to fire the build here. So let me go back to the metrics once. It was showing that complexity is 4.8 and the predicted number of issues is 21. So this depends on what are the lines of code, and so a lot of parameters are considered to come up with this prediction. Now let me go back to this one, and the build is successful here. So let's go back to the monitoring screen that I was looking at. So this is my Covair application showing the build, and let me just refresh this to see that the changes are happening or not. So 4.8 and 21 and 0.23 are the numbers. Those should change. Okay, not yet changed, so the data has not yet arrived into the ALM application. We are not yet able to see the change. I'll give it a few more seconds and refresh it to see whether the data is getting updated or not. Not yet. Alright, it's not yet here, so it will take about a minute or so to get refreshed. So this integration platform basically works in an event and action model. The event that is being trapped is build has occurred for this particular project, and what that is going to produce is this event is going to come to the integration bus, and there are some rules over there that's going to be processed, and once they are processed, the data is going to be sent to the ALM monitoring tool or the COVE application, and that should show me the current data. Let me do another refresh. So it's not yet here, it's taking longer than usual. Let me wait for a couple of more minutes to see whether it's coming up. Meanwhile, why don't you start sending your questions to the moderator so that we can take them up. Not yet. The build was successful. Don't know what's wrong. Let me just try and build it once again. I think the number has changed, isn't it? The predicted issues was not 30, it was 21 or something. Let me just check. Yeah, so actually the matrices have changed. I did not notice it. It is showing the ratio as 0.16. This was earlier showing up as 0.23. So as and when the builds are taking place, the matrices are changing real time, and also the prediction is changing. So if this goes to an alarming area, people can take corrective measures. So this is just one matrix that I have shown how it works in an integrated ALM scenario, but there can be matrices, similar matrices for requirements management, project management, and your defects, testing, coding, all the areas. So that brings us to the end of my demonstration, and also the presentation is done. So